Hello class, today let us prove one more identity, divergence A capital A dot C is equal to divergence A transpose C, where C is a constant vector, okay, and A is a second order tensor. Capital A is a second order tensor. Okay, now in order to derive this, we should know what is our LHS is representing, whether it is a vector or a scalar or a second order tensor. So what is A? A is a second order tensor, given A is a second order tensor. What is divergence of A? Whenever we apply divergence to any tensor, right, the order gets reduced by 1. If A is second order, divergence A will be first order tensor. The first order tensor, that is nothing but a vector. That is nothing but a vector. Okay. Now, divergence A is a vector dot C. What is C? C is also a vector. Right. So, the dot product of two vectors is a scalar. Right. So, this will be equal to the first vector if I take I. Right. C, for C also I should take I, because this part is a scalar. So, I. So, divergence A, I component. For C also I should take I. Now, in the next step, I want divergence A, I component. So, divergence A is representing a second order tensor, right? So, Aij, small aij, comma J. So, this part is representing divergence A, I component, and Ci as it is. Now, that is equal to, so Aij comma J Ci as it is. We are going to add a term here. What is that term? Aij Ci comma J. What is Ci comma J? C is a constant vector. It's a constant vector they have given. So, Ci comma J is 0. So, we are adding a 0 to it. So, these two are equal. Right? These two are equal. Fine. Now, in the next step, remember in the LHS we want transpose. In the LHS we want A transpose. What do we do is, if Aij are components of the tensor A, the interchange of Ji, right? Aji will be the components of the tensor capital A transpose. So, Aij, what am I going to do is, I am going to put A, capital A transpose, I am interchanging I and J. So, Ji, right, comma J as it is, Ci also as it is. Plus, similarly here, in the place of this Aij, I am going to take it as, A transpose, just watch the suffixes, interchange the suffixes, that is J and I. So, Ij is becoming Ji because I have taken transpose here, because I want transpose in my RHS, right? Okay. Now, in the next step, so we have, just watch the first term and the second term. So, what is my first term? First term I have A transpose Ji comma J, that is differentiation with respect to Xj, Ci as it is, plus A transpose Ji as it is, and differentiation of Ci with respect to Xj, because there is comma J, right? So, let me read that again. Differentiation of the first term, Ci as it is, second term as it is, plus second term as it is, differentiation of the first term. And that's nothing but, okay, the product rule. So, A transpose C, right, A transpose C, J, comma J. Why J here? Because I is dummy, right? Look at the first part, A transpose Ji, right, comma J, Ci. So, that whole thing is representing now A transpose C, J, comma J. J comma J. And that's nothing but divergence A transpose C. And that is our RHS. Right. So we have proved divergence A dot C is equal to divergence A transpose C. So C was outside with the dot product has gone inside here, right, with the ordinary product. Right. So that is the identity. So we shall stop now. We shall go to next identity in the next class. Thank you.